The skier will gain speed sliding downhill and then start a projectile motion under the influence of gravity. Initial projectile velocity of the skier is horizontal because of the ramp. Its magnitude is the same as the speed at the start of the ramp as there is no friction. Horizontal and vertical motion will be described by usual constant acceleration equations. On the horizontal there is no acceleration. On the vertical there is gravitational acceleration, g. Eliminating time between these two equations, we find the equation of the path, which is a parabola, as expected. The mountain slope can be described by an equation of a line with non-zero y-intercept. We chose the positive y direction same as g to avoid negative signs. The equations describing the skier path and the mountain slope constitutes a system of equations. Their common solutions, or in other words, intersection points, are potential landing points. Since the equation is a quadratic sin x, it can have up to two roots. It is instructive to note that both roots are meaningful in a sense. The first root corresponds to a projectile motion that started before t equals 0, where the skier jumps off of the mountain slope and passes through the point O at t equals 0. The second root corresponds to a landing point with a positive t, which is what we are looking for. Thank you for watching. Visit starleague.us for Physics Olympiad summer camps and courses.